Oh.
All right, so we had yesterday inequalities greater than, less than in one triangle. Today it's in two triangles. Before we go over these theorems, first of all, they are called the hinge theorem and the converse, otherwise known as side angle side or side 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 inequalities. But I'm going to focus on the word hinge, and I want to talk to you about where this kind of comes from and where it's good to think about. So I want you to think about my classroom door and Coach Chavez's classroom door. They are the same size, they're the same frame and everything. But if Tyson is going to slip out of here very quietly and that door opens on its hinges versus Chavez barreling out of his door, what is going to be the difference in the size the door has to open?
It depends on which way it opens.
Well, Tyson's barely going to slip out.
Oh. Well,
versus Chavez going out. He's a broader man, right? Okay, so which door is going to open more?
Chavez.
Thank you. So being on that hinge, we can actually compare that distance that Tyson gets out the door or versus Chavez getting out of the door. We can compare it based on the angle that it opens. That's what a hinge theorem is you kind of have to look at your two separate triangles, find the hinge, find the angle, and then compare the opening, okay? So I want you to think of it right here in your picture. Angle A is my hinge. Angle X is my hinge. In order to compare these though, you have to have at least two sides that are exactly the same in both. And they need to be the ones on either side. That's the side angle side. So I do have an equal length here and an equal length here, but my angles are different. This one opened for Chavez, 95 degrees. This one opened for Tyson, 45 degrees. Y'all go ahead and circle A, circle X, write the word hinges on there because I really want you to focus and see that that looks like a hinge opening. And notice again, those are equal distances. One just opened more than the other. So in comparison, if my angle over here is bigger than my angle over here, my distance that it had to open from BC and YZ, you have this comparison. BC is going to be greater than YZ because it opened farther. Okay, does that make sense?
If that was the door, wouldn't segment BA have to gradually get shorter or longer as opposed to keep that track for BC?
Well, the way this is drawn is very deceiving because this does not even look like it's the same length as this, but AC and BC would need, AC and AB would need to be kind of the same length nearly for the door to actually be on a hinge. But ultimately, you're looking for these are equal versus these are equal so that your hinge can be compared the same. Okay. All right. We totally converse that, and the same thing works down here. So this time on your picture, put a 12 on BC and an 8 on YZ.
But that means they're not equal.
That means they're not equal in length between the door frames, if you're still going to think of a door. A and X are still your hinges. So you still want to focus on where is that angle that was hinged, opening and shutting. And so up here we had the angles where we could compare the sides across from them, but down here we have the sides so we can compare the angles across from them. So conversing, same identical information except for this is in reverse, segments going to angle. And so obviously angle A is open bigger than angle X, and that's what I want you to highlight or point out right here.
Looks like a cone cavity.
It really does.
Okay, do we understand the idea of a hinge in those two separate triangles? The only thing we also have to have is those two congruent sides to know that that works. Okay, that's the notes. Let's look at some examples. Okay, so again, two triangles. We're going to look at the top two triangles, and y'all don't have to write anything, just kind of work with me here. I have my two triangles. First of all, I have to know, are there two sets of sides that are the same? So Skylar, looking with me? Do I have two sets of sides in the top two triangles that are the same?
Yes.
8 and 8, 15 and 15. And where are my hinges?
O and P.
Okay, so O at 95, P at 50. I'm circling them because I just want you to kind of visualize that's where the opening and shutting is happening. And if we're comparing O to P, O is larger than P. So Kyle, how can I compare MN to RQ?
O and P across from the,
Okay, and so which one of these has to be the larger segment?
M.
MN is the larger one because it's across from the angle that's opened wider. Okay? All right, we're gonna do the same thing here, but these are together. Triangles are together, so there's still two triangles. Let's find out if there are two sides that are congruent. Molly, can you tell? In these two triangles,
T and TR, that one is congruent.
TR in this one and TR in this one. Yes, do you remember the property name? Something equals itself.
Reflexive.
Starts with an R, reflexive. Okay, so that's reflexive, that's one side, and do they have another side? That's congruent.
SR and TU.
Okay, so I always have to check, I do have two sets of equal sides, and now I can see where my hinge is, hopefully, in between. Here's the hinge, here's the hinge. So this is not actually written correctly. Across from the 50 is what segment, Tyson?
T.
Across from the 20 is what segment, Tyson?
R.
I want to compare those. Which would be the larger one?
TS.
Okay, across from the 50 has to open larger than across from the 20. Okay, right? So if you can always watch for those congruent segments, find that hinge and notice which ones open more or less. All right? Okay, this one I want us to draw in our journals, and I want to do together because it's involving some algebra and solving. And we have not worked with inequalities with algebra in a while, so we're going to draw the picture and set up an equation together. Kyle? Skylar? We're drawing this one.
Oh, I was looking at this, like, is it on here?
Nope. I'm gonna move it up a little too, so that it's,
Does this go along with the same theorem?
yes, it's going in with the pink paper just somewhere as an example with it. So most of those numbers are designating side lengths. The 30 is a side, the 28 is this side, 12 is this side, 30 is this side. 52 belongs in this angle, and that's supposed to be an arrow, 1/2 x minus 6 in that little angle. Ultimately, we're going to use our inequalities, the hinge theorem, or the converse actually, to describe what the values of x could be. Okay, that means that I'm going to have a range from this number to this number, kind of like we did yesterday for our side lengths of our triangle. All right, let's do our examination. Kyle, do we have two sets of congruent sides in our two different triangles?
Yes.
Which pairs?
The lines where they're like put together.
Okay, that
I
one.
don't have a point name for that.
Good. And
the outside lines.
okay, the 30s are the same, and then they share a common side here. So we do have our sides that are the same. Our hinge would then be where, Skylar? Hinges?
52 and 1/2 x minus 6.
Those are my two hinges. I don't really have by numbers right now. I don't have a way to compare these without looking at the sides across from them. So this is why this is actually the side comparison. So Holly, looking at my 52 angle and across from it versus my 1/2 x minus 6 across from it, I'm going to make an equation out of this, well, an inequality. And I want to know which one of these things is going to have to be larger.
36.
Where did I get 36?
Is that not 36?
It is a 36. I don't know where I got that. It's just
I
a
was,
52.
honestly, I was so confused, and I was like, that's kind of.
No wonder you were confused. But yes, the angle that's across from the 28, the 52 that I should have had written there, is the bigger thing. So you see where we get an inequality. I don't know where 36
I like, I don't know.
I don't know what I was doing.
I
How do we
figured
know
it
it's
had
less than-
something to do with like, that's what the number should have been. So I was like, okay, if that was a 52, it would have been greater. So.
Okay, ultimately, across from those angles we were looking at the side lengths, this one has to be greater than this one because this is the bigger side. So the 52 is larger. Now, does everybody see where we got our equation? Inequality. So now comes the algebra skills that we've not practiced in a while, we're solving. And you treat these just like an equation. How am I gonna move my 6?
The opposite of what
Plus.
it is.
Opposite of whatever it is, so I'm adding it to give me 58. How am I moving my 1/2?
19.
Multiplied by.
Wait, no, that's not right. That's 20.
You are multiplying it by 2, or you're dividing by 1/2, either one. If you divide by 1/2, I'm gonna suggest you put that, just because putting this in the calculator gets confusing, unless you put that in parentheses, which is doable. But again, my suggestion is to do like what Holly said and multiply by its reciprocal. Because it seems weird, right? You're gonna get an answer that's larger than 58, but that's because you're dividing by something smaller than 1. So it turns that back around. Half of what? Half of what gives you 58?
29.
Half of what number gives you 58?
Oh, 160.
Yeah, we're turning it back around. We're multiplying by 2 to move it over here. So x is greater than 116. Okay. Oh no, I flipped my sign. Why did I do that? I'm just confusing myself all over.
Ow.
When is the only time I flipped that sign around?
If you divide by negative.
Okay, divide or
Well,
multiply by negative. Multiplying changes the value, division changes the value. So I don't know why I switched that, but I'm gonna fix it so that we get that right answer. So my values for x, if I plug in, could be anything less than 116, except for one thing. Can I have a negative value of that angle?
mm-mm.
Could I have a 0 value of that angle?
Mm-mm.
No. Could I maybe have 1 degree there? Maybe. But I can't have a 0 or below. So I have one more stipulation I have to add to this equation, so I actually have a range. My 1/2 x minus 6 has to be greater than what?
0.
0. So we have another equation to solve. So y'all help me. We're writing it down. I found my upper boundary has to be less than 116, but I have to find my lower boundary also.
X has to be greater than 12.
It's 3.
Because you added 6
Ski.
and then you multiply by the reciprocal
Yeah.
to get 12.
Divided.
Okay, so add 6, divide by 1/2 or multiply by 2. And now your final answer needs to look like it did yesterday. In terms of, let's
An
look at
and
this as a
statement.
range. So my smallest number it could be, well, my bottom number, my range is 12. My top number is 116. So I put my x in between. And then you're watching your symbols again. X has to be on the larger side of 12. So x has to be greater than 12. And x has to be on the small side of 116. Okay, that's my final answer, my range for what those numbers could be. Do you ever get that written down, please, in your journal? So you have that to look at if you get to use the journal on quiz. Okay, I have one more quick question. What would happen if this had been, hey, x has to be greater than 116, and that's my lower number? How would I find my upper number?
You do the opposite.
Okay, so I'm not going to be greater than 0 anymore. It's already greater than 0. What would I have to be less than if this is an angle in a triangle?
It has to be less than 80.
You got it. So if I need a lower boundary, it's going to have to be greater than 0 to make a triangle angle. But if I need an upper boundary, I would have to be less than 180 degrees to be an angle in a triangle. All right. So it just depends on what your equation looks like and how your answer comes out as to how you set up your other inequality. All right. How are we feeling?
Good.
Okay. Let's do the homework.
Can't complain.
Can't compute.